Now this one, you got 1 over a plus 6 over 1 over a plus 5. The way I like to solve this problem is I find the common denominator of the numerator and the common denominator of the bottom part, the denominator of that one. And once I find a common denominator between both of these all together, then I multiply that common denominator all the way through this problem. And in this case, it's really nice because what's the common denominator? Well, up here it's a, down here it's a. So if I multiply everything by a, every term, top and bottom, then what happens is, here, a over a is 1. I'm left with the what? A 1. Here, plus 6 times a is 6a. There's my top. Bottom, a over a, again, is 1. 1 times 1 is 1. Plus 5 times a is 5a. And there's my final answer. Again, the ones will not simplify out because there's a plus sign there. 1 plus 6a is one group, so we cannot separate unless we have that exact same group on the bottom. So that is my final answer. Here's to solve the equation. Also gives you a little clue. Think about cross multiplying. So what we might want to do here is go 2 over t equals t over 3t minus 4. And when it talks about cross multiplication, it's talking about taking numerator of this one times the denominator of that one. So 2 times 3t minus 4. And then what you're going to do is you're going to set that equal to the denominator of this one times the numerator of that one there. So t times t. And that's using the cross product. Then we got to simplify or work it out. Distribute, we get 6t minus 8 equals t squared. At this point, we need to get everything to one side because I have a t squared and a t. If I just had a t, I could solve for t. But I have a t and a t squared. That means factoring's got to be involved here to get my answer. So I'm going to move everything over here with t squared. Why? Because I don't want t squared to be negative. If that becomes a negative, it makes it a lot harder to factor. So I'm going to subtract 6t and add 8 at the same time. You don't have to do it at the same time. You can do it as 2 separate steps. That zeroes out, so what am I left with? A 0. Don't say nothing. Okay, don't put nothing there. You've got to have something there. And 0 is a number, so we've got to make sure it gets put there. And so there we go. We got t squared minus 6t plus 8. Now we're back to where we were a while ago when we did factoring using the zero product. So we got, write that down, t times t is t squared. Factors of 8, well that's not too hard, we don't have very many factors of 8, 1 and 8, and 2 and 4. You're done. Factors of 8, and when I add them, I get 6. So which one's that? The 2 and the 4. What about the signs? Well, this is a positive, that means they're going to be the same. Middle sign's negative, that means they're both going to be negative. And obviously we still got the equal 0, so don't lose that. Now we set both of them equal to 0. T minus 2 equals 0. T minus 4 equals 0. Solve for t. Add 2. T equals 2. Add 4. And t equals 4. And there's my final answers for that one. That was a pretty lengthy problem, so be careful you don't make any little mistakes. This one says, given the value of x and y, find an equation of variation in which y varies directly as y equals 60 when x equals 16. When it says y varies directly with x, that's y equals k times x. So what we're going to do here is we're going to plug in the values they give us. Well, they give us y is 60. They give us x is 16. So we plug those values in. It's just substitution. And then you solve for k. Divide by 16. So we get k equal to, well, what will go into 60 and 16? Well, I believe 4 will. 4 will go into 60. 15 times and 4 times there. So k is 15 over 4. Again, you should have a calculator, so you should be able to do that yourself. Then, once you get that k equals 15 over 4, it asks you to write the equation of the variation. So what they want to do is, now you're going to take that same y equals kx, but this time all you're going to do is plug in your k value. 15 over 4 and then x. And that'll be your final answer. You don't have to sit there and go through all the other stuff. That is your answer. They don't want you to plug any x or y's in. Now, every once in a while they will. They'll ask you for what is the y value when x is, 8 or something. If that was the case, then you would plug in 8 for x and tell what y came out to be. Now this one says inversely. The difference between inversely and directly is the equation is y equals k over x rather than k times x. Again, we're going to do the same exact thing. Substitute the y, 0.5 or 0.5 equals k, which is, we don't know, that's what we're looking for, and x is 32. To solve this, we multiply both sides by 32, which would give me 16, because 0.5 is half, and half of 32 is 16. So k equals 16. So what are we going to do? We're going to go over here, y equals k over x, and we're going to substitute in our k value, 16. And that is the equation of the variation which y varies inversely to x. Solve the system by graphing. Now again, we're going to be graphing. Now, since x minus y equals 2 and x plus y equals 6, again, I look at the coefficients on the x and the y. They go into the whole number that's on the end, the constant term there. So I go ahead and use x and y intercepts rather than trying to change them to slope-intercept form. To me, finding the x and y intercepts is just as easy because all you need is 2 points to determine a line. So I'm going to do this one in red. If I plug in 0 for x, that eliminates that, gives me a negative y equal to 2. Divide by negative 1, y equals negative 2. Watch the negative sign that you don't lose it. Now this one, when you plug in 0 for the y, the negative sign goes away. So we get x equals 2. And so 0, negative 2, that's this point right here. 2 zeros right here. So if I graph that line, it was just like that. Now, it's good to use a straight edge if you're going to solve by graphing because your lines, if they're not exactly straight, you may not land right on the point that you need to land on. So, and we'll probably check that out here in just a minute. Here, plug in 0 for x, it gives me y equals 6. Plug in 0 for y, it gives me x equals 6. That's why I choose the x and y intercepts, because you can do it fairly quickly. 0, 6, 6, 0. Connect the dots. And of course it didn't go exactly through it, but it looks like that point right there is at 4, 2. Now, is that right? Well, let's check it. 4 minus 2 equals 2. Is that right? Yeah, that worked. 4 plus 2, does that equal 6? Absolutely. So I got close enough to where I was able to tell what the exact answer is. The answer is where the two lines intersect. Another one. Now the first one is 2x plus 3y equals 6. Second one is y equals negative 2/3 x plus 7. On the first one, the coefficients will go into the constant term. So I'm going to go ahead and use my normal x and y intercepts. Plug in 0 for x. If I do, I get 3y equals 6. Divide by 3, and y equals 2. Plug in 0 for y. Plug that 0 in. It wipes out the 3 and gives you 2x equal to 6, divide by 2, and x equals 3. I usually like to use my x and y intercepts if they come out whole numbers. Now, on this next one, I'm not going to be putting it back into standard form like this one to see if it works. It's already in slope-intercept form. Y equals mx plus b form. So what I'm going to do is I'm going to graph it accordingly. Well, b is my what? My y-intercept. That's where I'm going to start, which in this case is a 7. So I'm going to start at the point 0, 7, because on the y-intercept the x value is always 0, so I know it's the point 0, 7. So what do? Go up here to 0, 7, plot that point. Now what am I going to do next? Well, I'm going to look at the slope, which in this case is negative 2/3. So my slope, which is the m value, which is the negative 2/3, which is rise over run. Well, look at that. Well, in this case, the rise is negative. So what does that mean? That means from this point, I'm going to go down 1, 2 units. And then I'm going to go 3 units to the right. 1, 2, 3 units to the right. Now, how many times can I do that? As many times as I want. Down, 1, 2, over, 1, 2, 3. I go down, 1, 2, over, 1, 2, 3. I can keep doing that until I get tired if I want to. Then each one of those points makes another point, and I can just graph my line. Now the reason I did so many there is because I want to try to make my line as straight as possible, because if I don't, I may not get the right answer. So 0, 2, or 0, 2, 3, 0, 1, 2, 3, 0, and then I graph that one. Wow, what do you notice about those two lines? It looks like they never intersect, does it? So therefore, that means they're parallel, and the solution is there is no solution. Why is there no solution? Because the lines never intersect, and the answer to this problem is where the two lines intersect. So since they're parallel, they don't intersect, there is no solution.